Good morning or good afternoon to everyone, and welcome to this webinar about stress analysis in static linear elastic simulations. I am Ruggero Poletto and I am talking on behalf of CONSELF, a new company that creates a new product of CFD and, in general, engineering simulations on the cloud. This webinar is part of a series of webinars that started in April, on April the 7th, and this is actually the last event currently in our schedule. During these webinars, we talked about heating, ventilation, and air conditioning systems. We talked about valves and pumps, and thus oil and gas simulations. And we also talked about architecture, with building and wind interaction. I suggest you all to register and follow us on LinkedIn, which is the channel in which we publish most of the updates about new events and also updates about our activities. Before proceeding, let's have a quick overview of the whole company. CONSELF was incorporated in April 2015, and is actually headquartered in Milan, Italy. We are increasing our network, distributors network worldwide, and we are currently present in 3 continents, in particular America, Asia, and obviously Europe. So I suggest you all to check our distributors list from our website page, conself.com/distributors. Let's have now a quick overview at all the services that CONSELF provides. These can be divided into 3 types of service. The first one is a simulation platform available on the cloud. So if you just type app.conself.com, you get access to a complete CFD and structural code to run your analysis independently from any other CONSELF consultant. You just need to activate your plan, and there is a wide range of plans available. We are going to see them in a little bit, and run the simulations. We also have a cloud computing service in which you can rent some of our computing power, and you can access it either by using SSH or by using remote desktop, and install any of your own software or the softwares available in CONSELF catalog, such as OpenFOAM, CodaStar, FDS, Fire Dynamic Simulator, or many others. Last but not least, CONSELF offers a consulting service in which our experts, by using all the applications I mentioned before, can help engineers and designers to improve their products. Moving closer to the application and to the goal of the current webinar, we can actually see the simulations we are about to run. So we have this mechanical piece. It is quite a simple simulation of a hole inside the flange, and we want to see the peak of stress next to the holes compared to the stress in other places of the flange. So we're gonna have a loaded boundary condition on which we are gonna apply a load, a force, an external force. And then obviously we have a fixed constrained boundary condition the one you can see in orange, on which we are going to apply a zero displacement condition. And with these two boundary conditions, we are able to run the whole simulations and to get an idea about the shear stresses and the normal stresses which are going to affect the piece, the mechanical piece we're going to analyze. So now, in order to run the simulation, I need to swap the view you're see. So I'll move directly my view to the browser, and I'll activate the CONSELF website. So 1 second, I'll activate the view to all of you. Here it is. So as you can see, I am now on a normal browser. This browser is Google Chrome in my case, but CONSELF application can actually work in any browser you want and from any operative system you may have installed in your computer. So I typed CONSELF website, so conself.com, and I suddenly got access to this website. The whole application is in the website, so you don't need to install anything on your computer, and you can run the simulation directly from the browser, as you're gonna see in this procedure. It's worthwhile remembering that all the hardware resources you need to run the simulation are provided by CONSELF, so you don't even need to have them. So I typed the login button on the top right, and I now have either to register to the CONSELF website or to type in my user and password. And now I just press the login button. I am forwarded to the application. So this is the website I mentioned before, app.conself.com. And in this application, I can control all the simulations I'm running remotely. So we have this first page, the dashboard page, on which we can actually have a look at the credits. Because considering the plan you have activated, you are provided a certain number of credits every month that you can use to run your own simulations. Obviously, if we move to the simulation tab, we can actually manage all the simulations, both the ones that are running and also the ones that we want to create, or the ones that we have previously run. So for the present tutorial, we just create a new mechanical simulation, Mac, and I just type create. Here it is. Obviously, everything starts from a CAD file, so we need to upload the CAD file. I put it on my desktop, and I can start the upload process. So this is the mechanical piece, as we saw earlier. And the first thing we need to do is to divide and to select the boundaries, as we saw previously in our slides. So I'll select these two faces of here, and I define them to be the fixed boundary we mentioned before. And I also select the top surface, this one on the top, to create the load boundary, the one on which we are gonna create the force. Everything else is gonna be selected, and everything has to go in another boundary we just call free. So we don't have to apply any particular boundary for this zone. The step file has been generated in millimeters, but CONSELF can handle multiple types of file units. At the same time, we can handle also internal and external simulations. So for this particular case, we just run internal simulation. So now the process is in background, and in this phase is the phase on which we are using CONSELF credits. So all the graphical part and the settings of the simulation is for free, and only when a process runs in background, we are using our credits. But let's go and have a look at the credits and how I can activate them. In CONSELF homepage, if you just scroll down a little bit, you access this part of the screen. You can actually see that we have 3 different plans plus a custom plan. The basic plan is for free and gives you 20 credits every month. Then there is a freelance plan for 199 euros per month, and this gives you access to 250 credits per month. And then we have an enterprise plan for 990 euro per month, and this gives you 1,500 credits per month. So once you have activated the plan you desire, you can access the platform and run the simulations you need. Now the geometry step is over, so I can move on to the meshing phase. So in here, we are defining the mesh types that for the current case is a hexahedral mesh. So it's going to be composed by cubes, and we have to define a certain dimension of the mesh, which is the dimension on the single element. We can also impose a certain refinement level as we approach as a particular boundary. But for the matters of the current tutorial, we just skip this phase because it's an advanced topic. So we just run the mesh, and I just apply. As we can see now, the simulation, actually the mesh is generated in background. So as we did before, we can move to a different part of the software, or we can even turn off the computer if we have something else to do. While the mesh is being calculated and generated, let's go and see the other section of the software, such as the storage. From the storage, we can actually see and we can manage the hard disk that CONSELF gives you on the cloud. So we can decide to delete some case which uses a huge amount of memory. Like here, we have a simulation that uses 4 gigabytes. And if I'm running out of space, I can delete it. So while the simulation proceeds, as you can see, we are now at 70%, so it won't take long for it to finish. We can see more sections available directly on the main screen of CONSELF, such as the user manual. This is a direct interface to all the options available in the simulation software. So I suggest you to have a brief overview at all the options available. There are videos, there are pictures, and there is also a detailed descriptions of all the options that through some images can also show you in a more accurate way, for instance, in this part, how we define a mesh. Something else very important is the fact that we offer a contact support service available directly on the application, and this support service is available 24 hours a day. So you can just contact our experts and get a feedback from them, such as help on running the simulations. So you don't have to run the simulation by yourself, but CONSELF experts can help you anytime you want. So let's move. The simulation is still running. Oh, it's over. So I can now open the mesh, the mesh which has just been performed. We are now in the mechanical definitions of the simulation, of the whole simulation. Before having a look at the setup, at the settings, let's see how the mesh has been generated. Here it is. It is a simple mesh, a uniform hexahedral mesh, because I didn't define any refinement or higher refinement level as we approach any boundary. For the present simulation, this is just a plane stress simulation, and we have to define the material properties we are using. The default values refer to standard steel, but obviously if you're using a particular steel or aluminum or other type of materials, we can actually handle this. Keep in mind that the simulation is a linear analysis, linear elastic analysis. So for the moment, in our online web application, we don't have any plastic analysis, but it is available on demand if you require it explicitly to us. We have now to define the boundaries, such as the fixed location at the bottom, the load location. So we have two different types of loads: a pressure, which acts normal toward the surface, or a force, which is a kind of integral interaction with the software. In our case, we just apply a force of -1 kilonewton in -z direction. And then we also, obviously, as we said before, we have the free surface on which we don't apply any particular boundary. So this part or these surfaces can move freely, basically. We can move on and see the time evolution. Apply just a steady time evolution for a certain number of time steps. We just leave the default values. We submit, I am. Now the simulation has started, so you can actually see that the simulation is running in background. We are once again in a phase on which we are using the credits we bought in our plans when we activated the plans. It's worthwhile remembering that the free plans provides you 20 credits per month. These credits are about 20 hours of simulations. For CFD simulation, they consist of, let's say, a couple, 1 or 2 simulations, but for mechanical simulation, they are much more. So it's worthwhile running simulations of CONSELF because you have for free a high number of simulations to perform. Keep in mind that the CFD and mechanical analysis, they are the part of the simulation we consume, which use the highest number of credits. So you need to double check if you have credits available before running these steps. And to do so, you just have to go to your dashboard. And this big pie chart you can see over here is a summary of the credits you have used. This small slice, we have used 890 credits in CONSELF accounts, and we still have 900,000 and even more credits available to run our simulations. So in here you can actually have an instant overview of the credits used, and you can still use. So the simulation is about to finish, as we are at 100% of the time. So a few more moments in order to have it done and to post-process the results from it. Let's just wait for the last bit of the simulation to get to a conclusion. And in this way, we can assess the result phase. It's worthwhile remembering that while the simulation is on process, you cannot assess. You just can assess simulation which are not in progress at the moment. So now here it is, the simulation is finished, so I can open it, and here it is, we are in the result phase. While the results are loading, I can show you that CONSELF provides a complete graph of convergence that you can save it just with a right click. And also you can assess the results both directly from the CONSELF web application or by downloading them and using some software such as ParaView, which is free of charge, or Insight, TechPlot, or other post-processing software available on the market. Obviously, this is a mechanical simulation, so most of the time we are interested into two parameters, the stresses and the deformation. So in order to see the stresses, we just have to activate sigma EQ. This is sigma equivalent, and it is calculated with a von Mises theory. So in here we can actually see we have about 3,000 pascals of tension in the area, in the red area of the mechanical piece, so next to the hole. And obviously we have a much lower tension in other places. At the same time, we can see the deformation of the material by clicking on this D parameter. So if I just activate it, I can actually see the deformation, which is obviously 0 in here at the bottom. Here it is. The blue means it's 0 because in here I applied a fixed boundary condition, but it is much higher at the top. It is also possible to have a overview of the deformed situation by applying this drop by vector field and use as a vector the, and by applying it. 1 second, it will take a little bit. We just increase the scale by 100 in order to highlight the deformation. And here it is. So we can actually currently see that it's been slightly deformed by the stresses we imposed. Obviously, you can have a much higher detailed result when you run it locally by using, for instance, ParaView. So with this, we have finished, let's say, the presentation. So I can move back to the overview of the presentation we were having a look together before. So just wait a few more seconds for me to present it. Here it is. And the last part of the webinar is for any questions you may have and you may want to ask to any of us. So feel free to use the top right icon, the one with the squares, and by typing Q&A, question and answer, you can make questions to me and I will be pleased to answer them. Let's wait a little bit for the question to come. Meanwhile, I remember that this webinar, together with all the webinars we had before, is going to be uploaded on YouTube. So you can actually see record of this anytime you want and from any device, obviously. And I'll also remember that we are going to put some more updates about the application live on LinkedIn. Probably I didn't say, but since this is a web application, any updates of the application itself is going to be made automatically, so you don't have to care about upgrading something like licensing or a plan or installing new software or upgrading the machines. That is done automatically, so just keep logging in and you'll get anything updated. So for the moment, no questions are coming. I'll proceed a little bit with some other contacts, such as our email address, info@conself.com. I suggest you to take advantage of it in order to make us questions and to invite us to keep developing new applications or new utilities for users to run their own simulations in millions of different cases. So a few more seconds for questions to come. It seems that today our public has not many questions. I hope I've been clear and good enough in the presentation. So I thank you all for participating to this webinar and to all the events that were previously done during the month of April and the month of May. I'll invite you to check out our website to find updates about future webinars and events. And I'll take, and please make questions, as I said before, and interact with us with all the socials. So since there are no questions, I consider this webinar complete. I thank you all once again for participating, and I enjoy the afternoon or get back to work safe and sound. See you later. Bye.